In this lecture we look at interference. Let's consider two identical point sources of sound that are in phase. Here we show a depiction of the two point sources, and the color is used to give you an idea of the intensity of the sound. Close to the point source, the sound is intense. Farther away, it's lower. Red is the high intensity, blue is the light blue is the lowest intensity. Where do these sound waves add completely constructively? This demo was provided by Wikipedia. And if we look along the black line that was just added to the picture, we see that all along the black line, the distance from each of the point sources to the line are identical. So L1 is equal to L2. If we look along this other black line that's just been added, it's where you see peaks going off an angle slightly upward. We see that L1 is shorter than L2. And it's shorter exactly by one wavelength, so that the wave emitted by L1 is a wavelength in front of the wave emitted by L2. Or if we look at this another one, we see going up at an even steeper angle. In this case, L1 plus 2 lambda is equal to L2. So it's the wave that is coming from L2 is 2 wavelengths behind the one coming from L1. Complete destructive interference, looking at the pink line where we only see light blue, that occurs when L1 minus L2 is equal to L2. So L1 is now farther away than L2, so you have to subtract off half a wavelength so that the two waves are perfectly out of phase. Let's look at an example of changing separation of sources. So again, we have two point sources that are emitting in phase, and they are separated by 3 wavelengths of the emitted sound wave. Okay, so here we have the depiction again. What type of interference occurs along the black line shown? So we have a black line going over there heading off to the right, and we see this constructive interference. And that's because the path difference from the sources to this line is always 3 times lambda, so it's always 3 wavelengths, so the interference is completely constructive because it's an integer multiple of wavelengths. If the separation between the sources is changed to 2.5 wavelengths, what type of interference would occur along the black line? Well, the path difference is always 2.5 wavelengths, so it's completely destructive. How would the interference change along the vertical line? Right now, with the separation of 3 wavelengths, we see that there is always constructive interference going on this vertical line. If we change it to 2.5 wavelengths, there will be no change with the separation. The path difference always remains 0 because all the points on that line are equidistant from the two sources, so it remains completely constructive.